Okay, in this problem we're given this rod AB. This is problem 15.43. We're given this rod AB, and we're told that it is 20 inches long. Now, we also have this point C right here. So here's point C, here's point B, here's point A. And point C, we're told, is 7 inches high and 10 inches from point A. And what we want to do is we want to figure out the angular velocity of this rod. So what's this angular velocity of AB? And what is the velocity of point B? So let's use our relative velocity method. And with our relative velocity method, we have the velocity of B is equal to our velocity of A plus our omega angular velocity of this bar crossed with the position vector RB with respect to A. We were also given, I forgot to mention this, A is moving towards the right at 25 inches per second. Okay, so let's draw our kinematic diagram. And in this diagram, we don't know what the velocity of B is, so let's give it a velocity of B in the y direction and a velocity of B in the x direction. We just don't know what that is right now. And let's look at the velocity of A. We know exactly what that is. It's 25 inches per second. And our position vector RB with respect to A, we start at A, we go to B. So that's going to be this right here. Now if we write down everything we know, we have a velocity of B. This is the two unknowns, so the velocity of B y has a j component, plus the velocity of B x has an I component. This velocity of A is 25 I. And we don't know this angular acceleration AB, so let's just say it's AB in the positive k direction. And what is this distance from here to here? Well, we can figure out what this angle is. This angle is going to be the inverse tangent of 7/10. And so this angle becomes right here, this theta is equal to 35 degrees. So this distance is going to be, this r of B with respect to A is going to be 20 times the cosine of 35I plus 20 times the sine of 35J. Now if we plug everything into our equation, we have VB xi plus VB of yj is equal to this 25I plus omega abk crossed with this 20 cosine of 35I plus 20 sine of 35j. Okay, if we evaluate this cross product, what do we get? If we evaluate this cross product, we get 20 times the cosine of 35 omega AB k cross I, which is a j, and we're going to get a plus 20 sine of 35 omega AB, and this last thing is a k cross j, which is a minus I, and so we put our I here and we distribute the minus sign. So this becomes our equation. we can equate our I and j components. So we have the velocity of b, x is equal to minus 20 times the sine of 35 omega AB. And the velocity, this is our I, and we have the velocity b of y is equal to 20 times the cosine of 35 omega AB. Well, this is not good. We have three unknowns. We have this velocity in the x, this velocity in the y, and this omega AB that we don't know. But we only have two equations. So what do we go about doing now? Sorry, this equation also has a plus 25i. I knew something didn't look quite right. It's this 25i right here. So how do we go about solving this equation? Well, what if we take a look at this point C right here? This point C is along this bar AB. So we know when this rotates with some angular velocity, it's all going to rotate with the same angular velocity. It's not going to rotate faster at this point than it is at the entire bar. So let's explore this part A to C. Now, if we do that, I'm just going to leave it open because it's not the end of the bar. Our point C, it's going to have two components of velocity. However, unlike B, which we don't know really what it's doing, we know the velocity of C has to be constrained along this bar. So this velocity of C is going to have a velocity of C times the sine of 35 and a velocity of C times the cosine of 35. It's different than B because B is at the end of this bar and it can sort of move in different, it's not constrained along the bar. This velocity of C is constrained along this angle that the bar is at. So we still have this velocity of A right here, which is 25i. So let's take a look at this velocity equation. We have a velocity of C, which we really don't care what the velocity of C is. We're just trying to use this part of the bar to get our angular velocity. So our velocity of C is equal to a velocity of A plus this omega AC crossed with the position vector from C with respect to A. So that's just going to be the position vector right here. And we're told we go over 10 inches and we go up 7 inches. So this is over 10, so 10i plus 7j. And this is r of C with respect to A. So the other thing, this angular velocity of AC is going to be the same. It's the same bar, so it's going to be the same angular velocity of AB. So if we solve this equation for omega AB, we can use it in this equation right here. Okay, so we have the velocity of C times the sine of 35j plus the velocity of C times the cosine of 35i is equal to 25i. And I'll move the cross product down here a little bit. I'm pretty bad at space management. So we have omega AB with a k, which is crossed of 10i plus 7j. So let's rewrite this equation, get it on the same line, do this cross product. We get the velocity of C times the sine of 35j plus the velocity of C times the cosine of 35i is equal to 25i plus 10 omega AB. K cross I is a J. And 7 omega AB, K cross J, is a negative I, so minus 7 omega AB. Okay, now let's equate our I and J components. Our I components right here, we have VC times the cosine of 35 is equal to 25, didn't forget it this time, but I forgot that I, minus 7 omega AB. Well, this is sort of a confusing equation. Let's see if J has a better, easier equation to solve for. So we have VC times the sine of 35 is equal to 10 omega AB. Well, yeah, this is an easier equation to solve for. So let's solve in terms of VC. So we can plug it into this equation right here and get what our omega AB is. We don't really care what this VC is. It doesn't really help us besides knowing how to find VC. So if we do that, we get VC is equal to 10 omega AB over sine of 35. We're going to plug this right here into this equation right here, and we're going to solve for this omega AB. When we do that, we get 10 omega AB over the sine of 35 times the cosine of 35 is equal to 25 minus 7 omega AB. If we solve for omega AB, we get omega AB, the angular velocity, is equal to 1.175 radians per second, and it's going to be, it's positive, so we know it's in this direction. Okay, so now we got omega AB. We can bring it back into this equation, and we can solve for we can plug it in right here and right here, and when we do that, we're going to get a velocity of b in the x is equal to 11.52 inches per second, and a velocity b in the y is equal to 19.24 inches per second. Now we can get the magnitude of this velocity, so our velocity of b is just going to be equal to the square root of 11.52 squared plus 19.24 squared, and this is going to give us 22.42 inches per second, or 1.86 feet per second. This is what the answer key has, but it doesn't really specify in the problem to do it in inches per second. And what angle is this at? Well, we can say it's 11.52. Let's move it down here a little bit. 11.52 this way. It's going up 19.24. So what's this angle right here? Well, like we've done a bunch of times, this angle is the inverse tangent of this 19.24 over 11.52, and we get this angle theta is equal to 59.1 degrees measured from the horizontal this way.